So before we can officially finish Chapter 4, I have a few minor topics that I want to talk about with you guys here in this video. These two topics are things that were added to the AP curriculum after our book was written, so they're not actually in our textbook and they don't pop up in the homework problems I give you from the book. Neither of these topics is very hard. They're just something we need to talk about though, because they do appear on the AP test, and it's also a good chance to review some of the big things we've talked about in this unit. Our first topic is going to give us a chance to review all of the nice sampling techniques that we learned in Chapter 4. And these first three options right here should be pretty familiar to you guys because we talked about them in quite a bit of detail. As a quick summary right here, SRS, a simple random sample, every group of size n, so this group of n people or this group is equally likely to be chosen. It's your most basic option that if you think about making a random sample just like before you took this class, you probably would have been describing an SRS. For a stratified random sample, you need to think of a variable that matters, or that you think will matter in the results that you get. My classic example that I use a lot is with freshmen, sophomores, juniors, and seniors. So I'd have each group separate here, freshmen, sophomores, juniors, and seniors. Each bubble is different from one another. This bubble is not the same as this bubble right here, etc. So you would need to do a problem where the year in school that you are would make a difference in how you would answer a question. So my classic example is prom, and if freshmen should be able to go, freshmen probably have different opinions than seniors. So what you do then, once you establish your bubbles, is you randomly sample some people out of each of your separate bubbles, and that becomes your sample. So you need to think of a variable that matters and separate into those groups before you do your sampling. A cluster sample, on the other hand, is when all of your groups are roughly similar to each other. So this group right here is about the same as this group right here, is about the same as this group right here. I use an apartment buildings analogy in one of them. Or, well, basically, whatever you want to think about it as, just realize that each bubble is like a mini version of your population. And with a cluster sample, you number off the groups, and group 1 is just about the same as group 2, just about the same as group 3. Once you have them numbered, you randomly sample the groups. Okay, I got number 2 and number 7. And everybody in those bubbles becomes your sample. It's still random, but the randomness happens in which of the bubbles you select. Those three we've already learned about. That was just a quick refresher. The new one that we are talking about in this lesson is a systematic random sample. And let me describe what a systematic random sample is, because we'll talk about it on the next page with the definition. But just to give you guys an intuitive idea, you see this in situations like with exit polls for surveys. So like for elections and stuff like that, they do exit polls, so they have a pretty good idea about who's going to win before the official results are even posted. If you watch the news during elections, they'll call a state and be like, this state is going for this candidate before the results are made official. And it's because the data from the exit polls is just so strong. The thing about doing an exit poll, though, if you're going to do a survey, you don't know how many people are going to show up that day. So if I'm trying to do a random sample of people going to a poll, I don't know what to take it out of. I don't know how many people I need to choose for my sample because I have no idea how many people will show up. So what you do is, like, let's say you decide I want to talk to every 10th person who shows up. So what I would do is I would randomly pick a number from 1 to 10. And like say I get 8, person number 8 that day is my first person that I go to. And then after I hit that person right there, every 10th person after that I would go to. Systematic kind of conjures up an image of there's a system to it. So every 10th person, every 15th person or whatever, you're going to talk to that person. The randomness is in where you start. So what's your first person? And then from there, you go every nth or kth or whatever you want to call it person. So that's what a systematic random sample is, and that is the new topic of this video right here. This definition in blue basically explains what I just said. Pick your starting point randomly, and then after that, every blank person is going to be the people that are in your sample. This works really well too when you want to do surveys in public, like if you want to just go and find out the opinion of people at the Galleria or at the mall or something like that, because you don't have a list of everybody who's going to be there, and you don't even know how many people are going to be there. So in that situation, a systematic sample can be useful. So it's very useful in public, or where you don't know, or where you don't have access to a list of the population. And the big drawback to a systematic random sample is if there's some sort of a pattern. Like, let's say that people, every fifth person ends up being an older person or something like that. That's a weird example, I guess. But like, if there's something going on where there's a pattern to the population, then going every 10th person or every 15th person or whatever, you might end up missing parts of the answer or being fooled by the pattern. So when you have a pattern in the population, a pattern in the order of the population, you might get tricked by that when you are doing a systematic random sample. But if your population is pretty evenly distributed in the way you have it listed out, then a systematic random sample is a good option for how you can collect a sample in a good way that doesn't fall into some of the traps of not knowing what your population actually looks like. So the second topic of this video is pretty quick. We're going to talk about the difference between, we'll talk a little more about observational studies. So the first thing I want to talk about here is a review of the difference between an observational study and an experiment. And we know already that in an observational study, treatment is not imposed. So that is the big thing going on there, is that you're not imposing treatments when you do an observational study. That's the magical answer. You just give context and you're good to go. In an experiment, you are manipulating a variable and imposing treatment on subjects. We have here just a breakdown of two types of observational studies. There's what's called a retrospective and a prospective or prospective observational study. In a retrospective observational study. So in both of these scenarios right here, you're not imposing treatment. You know what an observational study is already. In a retrospective study, the data has already occurred. The data you're collecting, so the data being collected has already occurred. Okay, the word retro makes you think old, already happened, retro 80s, stuff like that, stuff in the past. So if you're doing a retrospective study, it's data that's already happened in the past, and you're kind of going and you're looking at it and analyzing it. So you could do a retrospective study just by Googling things and finding data piles that are already there online. You could also be bringing people in for a study and asking them about stuff that has already happened to them. So if the data of interest has already been already happened, even if you haven't collected it yet, that's a retrospective study. Whereas a prospective observational study, your data collection will occur in the future. So data will occur in the future. So maybe I want to test some sort of effect on smoking or something that's going on right now, and I want to see what kind of health effects that'll have on you in the future. I'm clearly not going to force you to smoke or not, so it's not an experiment, but I could ask people to identify if they're smoking or if they're doing this or doing that, and then follow up with them in 5 years, 10 years, next month, whatever, and check on their status then. So that's just a little bit more of a detailed look at observational studies, whether your data happened in the past or whether it's going to be happening in the future.